In this video, we are going to predict the solubility of organic compounds in different solvents. We can see that 5% HCl, 5% NaOH, 5% NaHCO3 are in aqueous medium. And so if a compound is soluble in water, it would also be soluble in these because these are all aqueous solutions. And then we have concentrated sulfuric acid and we have diethyl ether. Diethyl ether is a nonpolar solvent. Diethyl ether has an ether linkage and ethyl groups on either side. So recalling that like dissolves like, nonpolar organic compounds will likely dissolve in nonpolar solvent like diethyl ether. Let's take the first compound, glycerol. Now, glycerol has 3 OH groups, and these OH groups can form hydrogen bond with water. So it has 3 OH groups which are hydrophilic. They can form hydrogen bonds with water, and so glycerol is soluble in water. And if it is soluble in water, it will also be soluble in HCl, NaOH, and NaHCO3, which are dilute solutions in water. Now let's consider the solubility of glycerol in diethyl ether, which is a nonpolar solvent. Now, glycerol has 3 hydrophilic groups, the OH groups, and that's dominating compared to the feeble hydrophobic group here. And so glycerol is mainly polar in nature, and so it is insoluble in diethyl ether. Next is 2-butanol. 2-butanol structure is as follows. So 2-butanol has a hydrophilic portion here and it has hydrophobic portions here. So because of this, there is a competition between the hydrophilic and hydrophobic portions to interact with water. The hydrophilic portion favors the formation of hydrogen bonding with water and favors the solubility. However, the hydrophobic portions can come on the way inhibiting the formation of hydrogen bonds, leading to secondary butanol being insoluble in water, and so it's also insoluble in aqueous solutions of HCl, sodium hydroxide, and sodium bicarbonate. However, the hydrophobic nature of the alkyl groups here makes it soluble in diethyl ether. In concentrated sulfuric acid, 2-butanol can get protonated, so we can say it is soluble in concentrated sulfuric acid. Now triphenylmethanol, if you see this, you can say that this is the hydrophobic part, which is so bulky, and this is the hydrophilic part. So we can expect triphenylmethanol to be insoluble in water. So if it's insoluble in water, it's also going to be insoluble in aqueous HCl, NaHCO3, and NaOH. Triphenylmethanol in concentrated sulfuric acid, it's soluble and it forms the cation. So if this is triphenylmethanol in concentrated sulfuric acid, it forms the cation because concentrated sulfuric acid is dehydrating, so it takes away the OH, forming the cation. and this can be colored as yellowish. In non-polar solvent like diethyl ether, because of this group, triphenyl methanol will be soluble in diethyl ether. Next is aniline. Aniline is a benzene ring with an amino group. Now, the hydrophobic nature of benzene makes it non-polar, and so aniline is insoluble in water. Now let's look at aqueous HCl or 5% HCl. In 5% HCl, aniline is soluble because the amine is basic in nature, and because this is basic in nature, it can react with HCl to form salts. So we get aniline. So the reaction is RNH2 plus HCl gives RNH3 plus Cl minus, and so this is soluble. However, in 5% NaOH and 5% NaHCO3, it's going to be insoluble. Aniline with sulfuric acid, again it forms a salt to give you RNH3 plus HSO4 minus, and that is soluble. Now diethyl ether, because of the hydrophobic nature of the benzene ring, aniline is easily soluble in diethyl ether. The next compound is benzoic acid. The next compound is benzoic acid. Benzoic acid has a benzene ring with a carboxylic group. And since we have seen that the carboxylic group is a strongly polar group, benzoic acid is soluble in water. And because it's soluble in water, it's also soluble in dilute solutions of water such as HCl, NaOH, and NaHCO3. So I'm not going to write that here because it's implied. Coming to concentrated sulfuric acid. Coming to benzoic acid's solubility in water is limited. Okay, so you can say that it's poorly soluble in water, okay, or very less soluble in water. But due to the acidic nature of the carboxylic group, it's highly soluble in sodium hydroxide. So in sodium hydroxide, benzoic acid can form the sodium salt of benzoic acid. Again, in sodium bicarbonate also, benzoic acid can form sodium salt of benzoic acid. So again, it's soluble in NaHCO3 as well. In HCl, we can imagine that it will be insoluble because it's poorly soluble in water, so it would be poorly soluble in HCl as well. Coming to concentrated sulfuric acid, benzoic acid is not soluble in concentrated sulfuric acid because they are both acids, and so there's not much reason to react. In diethyl ether, benzoic acid is soluble because of the hydrophobic benzene group. Dioctyl sebacate. So this, from the name, we can say that this is an ester, and this is an ester of sebacic acid and an octanol. Sebacic acid is this, CH2 8 times, COOH. It's a dicarboxylic acid with the carboxylic groups on either side. So this will be the hydrophobic portion, and the carboxylic groups are the hydrophilic portions. From the structure of the dioctyl sebacate given, which is so this is the structure of dioctyl sebacate that is given to us. Here, this is the dicarboxylic acid. This is a sebacic acid portion, and these are the, so here we see the two carboxylic groups. This is the hydrophobic part of the sebacic acid, and this is the octanyl portion, the octanol portion. So we can see that there are 8 carbon atoms on either side for the octanol, and it's a branched octanol. So we can see that the hydrophobic portion dominates, and so we can expect this to be insoluble in water. And because it's an ester group, there is less reason to react with 5% HCl or 5% sodium hydroxide or 5% sodium bicarbonate. So it's insoluble in 5% HCl, 5% NaOH, and 5% NaHCO3 as well. And this ester is soluble in diethyl ether. Let's look at naphthalene. Naphthalene is 2 benzene rings together like this. It's completely nonpolar, visibly nonpolar with no functional groups to provide any polarity. And so it is insoluble in water and insoluble in all the dilute solutions of HCl, NaOH, and NaHCO3. And it is highly soluble in diethyl ether.